Hi, in this video we are going to talk about bipartite matching, the application of maximum flow. So let's get started. There is lots of applications of maximum flow, and one of the most important applications is the bipartite matching and maximum flow. But let's start with the bipartite matching. In graph theory, a bipartite graph is a graph whose vertices can be divided into two disjoint sets U and V, such that every edge connects a vertex in U to one in V. So what does it mean? It means something like this. We have 4 nodes in the set U, we have 3 nodes in set V, and there are several edges pointing. In this situation, these edges are undirected, and usually in a bipartite graph, these edges are undirected, but of course we could use directed edges as well. So there are several edges connecting these nodes from disjoint sets U and V. So this is how disjoint sets look like. And for example, the problem is that suppose we have a set of people P and a set of jobs J. We can think that in this situation the set U is the P, the set V is the jobs. So each person can do only some of the jobs. For example, if someone is an economist, he can make, for example, stuff concerning quantitative finance in investment banks and so on. If someone has a certificate of, for example, Java programming, then of course he can do programming stuff and so on. So each person can do only some of the jobs, and we can model it as a bipartite graph. What is a matching? A matching gives an assignment of people to tasks, and a maximum matching contains as many edges as possible. So we have people and we have jobs, and we want to assign as many people to as many jobs as possible. Find an assignment of jobs to applicants in such that as many applicants get jobs as possible. Yeah. So for example, we have the set U. It contains the applicants Adam, Sally, Joe, and Kevin. We have the set V. It contains the jobs, for example, a job at Google, a job at Morgan Stanley. It can be some quantitative finance stuff, for example, concerning stock markets and arbitrage situations, Black-Scholes model, and so on. ExxonMobil, for example, if you are an economist or so on. And we want to, and of course, these edges represent that, for example, Adam can have a job at Google as well as Morgan Stanley. For example, it can be the situation when he's a software developer with some interesting quantitative finance, then he can get a job at Google as well as in Morgan Stanley. Sally is, for example, he can have a job at ExxonMobil only, and so on. So we can construct this bipartite graph without any problem. We just have to know the competences of the people. And for example, this is a maximum matching. So Kevin get a job at Google, Adam at Morgan Stanley, and Sally at ExxonMobil. And Joe, of course, one of the applicants, will not going to get a job because there are 3 jobs for 4 people. So I think it's pretty straightforward. And how can we solve this problem? As I said earlier, we can use the maximum flow algorithm. We just have to create 2 extra nodes, the source, the S, and the target vertex, the T, or the sink, whatever we prefer. We have to connect these source to the names, I mean the applicants, and we have to connect the jobs, the firms, to the sink. And all the capacities are 1. And we have to run our Edmonds-Karp maximum flow algorithm on this network, this constructed network, and then we get the maximum flow. So we just have to find the maximum flow in the constructed network, and the maximum flow is equal to the maximum matching. So how many people can have a job in the optimal solution. So this is how we solve this problem. We have the applicants, we have the jobs. We just have to create 2 extra nodes, the sync and the S node and the T node. We just have to connect the S to all of the applicants. We just have to connect the T to all of the jobs. And of course, we have to assign a capacity 1. It's very important that each of the capacities will be 1. And we just have to run our Edmonds-Karp algorithm in this constructed network. And it is going to solve the problem for us. So that's how bipartite matching works. Thanks for watching.